All right, so now we're on to 13.50. What is the molar concentration of glucose, a sugar, made by dissolving 24 grams of glucose in 1 kilogram of water? Okay, so we want the molar concentration, and then we want the mole fraction, and then we want the mass percent. Okay, so we have to remember what these values, what these words, what these ways of expressing concentration mean. Molal means moles per moles of let's see, solute per kilogram of solution. So let's find that one first, right? So we have 24 grams and we're dissolving it into 1 kilogram, right, of water. And again, molal, little m, underlined like that, means moles of solute over kilograms of solvent. So we can find moles of solute here simply by looking at 24 grams and determining how many moles of sugar that is, right? So this stuff, C6H12O6, that has a molar mass of 180. You can add that up. It's glucose. So 180 divided by 24, right? So it looks like, oh, other way around, 24 divided by 180. That's how many moles of glucose we have, 0.133. So that's 0.133 moles of solute, glucose. Okay? And then we're going to divide that by kilograms of solvent. Now the kilograms of solvent, we see that there's 1 kilogram of solvent, so that's 1 kilogram of water. So then we can divide that by, just 1 kilogram. So that 0.133, that should be our molal, right? It should be 0.133 molal glucose. So that is number 1350, and we can take a look here in the back of the book. 1350.133 molal. Okay, good. So then we're going to go on to the rest now. What is the mole fraction of glucose in the solution? Mole fraction. Mole fraction, all right, X, mole fraction. That's moles of solute over total moles. Now total moles is the same as moles of solute plus moles of solvent. So mole fraction is also moles of solute over moles of solute plus moles of solvent. Okay? So all we have to do here is we have to identify how many moles of solute and how many moles of solvent. We already know from above that we have 0.133 moles of solute, so that's 0.133, right? Moles of solute divided by 0.133, that's moles of solute, plus moles of solvent. Now I have a kilogram of water, so that's 1,000 grams, and I can divide that by the molar mass of water, 18, and that tells me that I have 55.5 moles of water. 55.5 moles of solvent. This is moles solute. This is moles solute. Correct? All right, so to find the mole fraction of the glucose, and that's what we're after, what's the mole fraction of glucose in the solution? Whoops, where's the question? Oh, right here. What's the mole fraction of glucose in the solution? All right, we can just take the 0.133, take the 0.133, and then divide it by the 0.133 plus the 55, right? And the answer is 0.024. 0.0024. 0.0024. That is, and mole fraction is represented as X. So the mole fraction of glucose. All right, so we'll double check with that one. Mole fraction, number 50, correct? 0.239 times 10 to the minus 3. Okay. 2.39, sorry, times 10 to the minus 3. All right, so that's correct. And now we're after the mass percent of glucose. Now, mass percent means how many grams of solute for every. Let me move this down just a little bit. How many grams of solute per liter or 100 milliliters of solution? Grams of solute per every 100 milliliters of solution. All right, so we're looking for mass percent, which is grams of solute for every 100 milliliters of solution. All right, so grams of solute, we know we have, it said right there, 24 grams of solute for every 1 kilogram of water, 1 kilogram of water. So how many milliliters of solution would that be? How many, sorry, 100, this is 100 milliliters, right? This is 100 grams of solution, 100 grams of solution. So if I put 24 grams of glucose into 1 kilogram of water, how many grams of solution would I have? Well, 24 grams divided by a total of 24 plus, because 24 of the solution's mass is from the glucose, and then the other mass is 1 kilogram, so 1,000 grams. So if you took the 24 grams and divided it by 1,024, that's the grams of solution. This would be now grams of solute, not for every 100 grams of solution, but for every 1,024 grams of solution. So if we got this value, found out this value, we would say 24 divided by 1,024, and then we would, that's how many grams there are for every single gram of solution. But we want to know how many grams there are for every 100 grams of solution. That's what percentage means. So I have to just multiply this by 100. So then I see that it's, whoops, I divided it by 100. So I see that it's 2.34%. All right, so we can double check with that one, 350, 1350. .34%. All right, excellent. Okay, so now we're working on 1352. A solution of ethanol in water has a concentration of 1.25 molal, and we want the mass percent. Okay, so the way we can do that is we can we know we have 1.25 moles of ethanol for every 1,000 kilograms, 1 kilogram of water. Now, it said it's ethanol is in water, so that's how we knew that water was the solvent, and ethanol is the solute, right? So, and 1.25 molal means, again, 1.25 moles of ethanol for every kilogram of solvent, which is a kilogram of water in this case. And now we want mass percent. Now what does mass percent mean again? It's grams of ethanol, or grams of solute, which is ethanol in this case, for every 100 grams of solution. All right, so in this thing, and sometimes it helps again to draw ourselves a little bottle to kind of think about what's going on here. In this scenario here, we have a container or some solution, and it's 1.25 moles of ethanol, and it's 1 kilogram of water, right? 1 kilogram of water. Now, we can just talk about this container, just kind of fix it on this container. If you don't fix it on that container, if you start trying to solve this problem without kind of thinking about that container, then you're going to say, well, you mean how many grams of ethanol for 100 grams of solution? But I don't know how many grams of ethanol for every gram of solution. Well, you do know. You can figure it out because you can just think about this scenario here. All right? So right now I have 1.25 moles of ethanol and 1 kilogram of water. Now, how many grams of ethanol is that? Well, ethanol. Ethanol has a molar mass of what? That's 12 for the one carbon, 12 for the second carbon, 16 for the oxygen, and then 3, 4, 5, 6 for the hydrogens. So we got 46 grams for every mole. So this is 1 mole, and there's 46 grams for every 1 mole of ethanol. This will tell me how many grams of ethanol I have, right? So 1.25 times 46 equals 57.5. So we got 57.5 grams of ethanol. And in here as well, oops, sorry, this wasn't part of this little problem here. But in here as well, we have a kilogram of water. So in this container right now, I see that I have how many grams of solution? Well, the solution, it contains 1,000 grams of water and 57.5 grams of ethanol. So that's a total of 1,057.5 grams of solution. So I can take grams of ethanol over grams of solution, and grams of ethanol is 57.5. 57.5 over 1,057.5 grams of solution. This is grams of ethanol, right? That, the answer to that will tell me how many grams of ethanol I have for every gram of solution. So I divide that by 1,057.5, and then that value right there, 0.0543, is how many grams there are for every gram of solution. So I have to multiply by 100 because I'm interested in, oh, not divide by 100. Because I'm interested, 5.437. I'm interested in how many grams there are for every 100 grams of solution. So we have 5.437 percent ethanol. All right. So that's how we solved number 1352. Let's double check and make sure we got the right answer here. 1352, 5.45%. So we were off a little bit, but probably because the molar mass of ethanol was a little bit different than just 46, but that's all right. We're okay. All right, 1354. A solution of ammonia in water has a concentration of 7.5% by mass. Calculate the mole percentage of ammonia in the solution. Mole percent. Mole percent. Well, I don't know if you can tell what mole percent means simply by listening, knowing his name, but mole percent means moles of solute over moles total. All right, calculate the mole percent of ammonia in the solution. And then we have to determine what the molar concentration of the ammonia is. All right, so 7.5% by mass. Now, what does that mean? That's maybe the hardest part of this problem, right? What does that mean? Well, 7.5% by mass means 7.5 grams of ammonia, NH3, for every 100 grams, that's what percentage means, of solution. All right, so that's what we have there. Therefore, if I have 100 grams of solution, here's the container that has 100 grams of solution, right? Of this 100 grams of solution, 7.5 grams is the ammonia, and the rest is, it says water. The rest is water, because water is the solvent here, right? So the rest is water. So here I have 100 grams of solution, which is 7.5 grams ammonia, and how much water, how many grams of water? Well, I take 100 minus the 7.5, and is 92.5 grams of water, right? All right, good. So that's what this information means. I can find out the moles of ammonia and the moles of water, right? (18 grams for 1 mole of water, 14, 15, 16, 17 grams for 1 mole of water. So then I take a 7.5 divided by 17, that's 0.4412, and then the other one is my 92.5 divided by 18, 5.13. So the moles total, wait, did I do that right? Yes. The moles total is this plus this. That's my total moles. And I want to find the percent moles. So what is the percent moles of, what is the percent of ammonia? Calculate the mole percent of ammonia. So then I go up here to the moles of ammonia, which was this value right here, right? And I divide it by the total moles. Times 100, 7.9%. All right, so that should be 1354. 7.9% for 1354. 7.89%. Okay. And the other part of the problem, what's the molar concentration of ammonia? The molar concentration of ammonia can be found by what does molar mean, right? We just have to think about what molar means. Molar means moles of solute for every kilogram of solvent. All right? So I know that I have 0.4412 moles of the ammonia here, 0.4412 moles of the ammonia. So I can say 0.4412 moles of solute. Now I need to divide that by the kilograms of solvent. So I know that this many moles of water was actually 92.5 grams, which is the same as 0.0925 kilograms of the solvent, which was water. Right? So I get my moles of ammonia here, and then divide it by the mass of the water, which was up here. I calculated there, right? 92.5. Oh, it's actually not 92.5, right? We have to divide it by 0.0925. That's kilograms, right? All right, so we got 4.8 molar. All right, let's see if we got it right. 1354. 4.76 molar. Close enough. All right. So 1356. We have a solution of sodium nitrate. Concentration is 0.363 molar. 0.363 molar. Right? So 0.363 molar means moles of sodium nitrate for every 1 kilogram of the solvent, which is water. We have some density given to us, and we want to calculate the molar concentration. the mass percent, and then the mole fraction of that in solution. So we want the molar, that's big M. We want the mass percent, and we want the mole fraction, which is our X. Okay? Molar means moles of solute per liter of solution. All right? If I know that this is how many moles of ammonia or sodium nitrate I have, and that's how many kilograms of water I have, that's molality, right? I can identify how many total grams of solution I have in my container, right? So again, draw a little container. In this container, again, I have a kilogram of water and that many moles of sodium nitrate. I could find the molar mass of sodium nitrate. Sodium, 23. Put this into my calculator, 23. NaNO3. Nitrogen, 14. And oxygen, 16. But there's, three oxygens, right? So I'm getting a, here's the sodium, the nitrogen, 14, Na, N, and then there's our three oxygens. So I got 85 grams per mole. So if I started off with 0.363 moles, right, and for every 1 mole of this NaNO3, there's 85 grams. So if I take the 85 grams and multiply it by 0.363. Whoops. 0.363. Then we got 30.85, and that's how many grams. 30.85 grams of sodium nitrate with the 1,000 grams of water. And that's from this understanding up here, that there's 1,000 kilograms of water, or 1 kilogram of water, 1 kilogram of solvent. All right, so now I want liters of solution. And I can get that from the density because I know that there are 1,030.85 grams of solution. That's the sum of this stuff and that stuff, right? And what else do I know? I also know that there are, I know the density, right? The density. The density is there's 1.085 grams for every milliliter of this stuff, right? So then I can find out what the volume of this stuff is. It's 1.85 grams for every, 1.0185, sorry. 0.185 grams for every milliliter. So if I have 1,030.85 grams of solution, and I know that there's 1.0185 grams for every 1 milliliter of solution, I can get milliliters of solution. Now, why is milliliters of solution important? Because, liters of solution is necessary to find out the molarity, which is moles of solute per moles of solution. So, from this here, I can find out how many milliliters of solution, 1,012.112. That's how many milliliters, and I can divide that by 1,000, 1.012 liters of solution. And I can put moles of solute, 0.363, over that, and that should be my molarity, right? So I take 0.363 divided by this value here, and my molarity is 3.59 times 10 to the minus 4. All right, 356. Let's see if we got the right molarity there. 1356. 1356. 0.359 times 10 to the, no, let's see, 1356, 0.359. Oh, I must have missed something there. 0.359 times 10 to the minus 4. What did I do here? I took 0.363 and divided it by, oh, that's the problem. I divided it by how many milliliters of solution, not liters of solution, so this needs to be multiplied by 1,000. Whoops, not 100, 1,000. And then that's my molarity, 0.359. Okay, good. Now I need to calculate the, wait a second, is this what I want? Yeah, then the sodium nitrate. I just calculated the molar concentration. Now I need to know the mass percent of the sodium nitrate in solution. Mass percent, that is grams of sodium nitrate, grams of solvent, or solute, for every 100 grams of solution. Alright, so I identified earlier that we had 30.85 grams of sodium nitrate. And I can divide that by grams of solution. Grams of solution, I found that there was 1,030.85 grams of solution here, right? Now that won't tell me the percent, that'll just tell me the grams of solute per gram of solution. But then I can divide that by 1,000. Or 100, sorry. Divided by 1,030.85 times 100. So it should be 2 or 3.0%. So we'll double check on this one. 1356. 3.00%. And there's the molarity. I don't know if you saw that last time. Okay. All right. The last thing we're looking for here is, what is the mole fraction of sodium nitrate? Mole fraction is done, again, mole fraction means moles of solute over moles total. Okay, so how many moles of solute were there? 0.363 divided by total, which is 0.363 plus the moles of solvent. Moles of solvent, how much solvent was there? Well, I know that there was a kilogram of water, so I can take that mass, which is 1,000 grams, and divide it by 18 and see that there's 55.5 grams. So I can add that to 55.5 to the grams amount of moles of solute, and then I can take my 0.365 divided by 0.365 plus 55.5555. All right, so now that's just the mole fraction. Oh yeah, and that's all I want is the mole fraction. So 0.0065. If I wanted mole percent, then I multiply that by 100. All right, so what number are we on? 1356. .00649. Okay, so I got 0.0065. So close enough. All right. Now moving on. 1358. At 25 degrees Celsius, the vapor pressure of water is 23.8 torr. Okay. Then what's the vapor pressure of water after we dissolve? 65 grams of that stuff. C6H12O6 looks like glucose to me. All right, but if we dissolve some of it in 150 grams of water, what is the vapor pressure of the solution? Now, vapor pressure How is vapor pressure affected when you dissolve something in it? Well, if you think about the vapor pressure is going to be the average of the vapor pressures of the different things that are in the solution. So if I have vapor pressure, if I have water, for example, in a solution, just going to draw a quick picture here. If I just have water, and apparently at 25 degrees Celsius, the vapor pressure of the water by itself is 23.8. That's what the first part of this sentence says, right? 25 degrees Celsius, the vapor pressure of water is 23.8 torr. All right, here it is. That means that the water molecules that are above here are putting a pressure of 23.8 torr on that lid, trying to push it off. Now, if I put some ethanol into here, right? So now I have not just water, but I have some ethanol as well. Now, if it was just another bottle with only ethanol, the vapor pressure of this one would be higher because it has less intermolecular forces holding it together. It evaporates at a lower temperature. So at the same temperature, water and ethanol is going to have less of a vapor pressure than just ethanol by itself. Now, where would water be compared to these ones? Where would just water all by itself? Would it be more or less or what? Well, obviously water would be less than all three, in the least of all three of these, right? So you have water combining with ethanol, and now the new vapor pressure is somewhere in between the water and the ethanol. All right? The vapor pressure ends up being related to the fraction of the material that you have, the molar fraction. So, for example, the resulting vapor pressure, right? The vapor pressure of the total solution here, right, is going to be equal to the mole fraction of the water times the vapor pressure that the water would be exerting all by itself, plus the mole fraction of the ethanol times the vapor pressure that the ethanol would be exerting all by itself as well. If it's half water, if this is 0.5 and this is 0.5, then the resulting vapor pressure would just be the average of these two, right? So the vapor pressure total depends on what the mole fraction is. So then we need to find the mole fraction of the different components in this sample. So 25 degrees, the vapor pressure of water is 23.8. What's the vapor pressure of the solution prepared by dissolving? Oh yeah, and then I need to tell you one more thing. In this case, it says that what we're dissolving into the water is non-volatile. It's non-volatile. So essentially, the vapor pressure here is going to be 0. Because it's not ethanol, it's something non-volatile. So in this case here, we have some water, which has some vapor pressure, right? And the vapor pressure total is going to be equal to still the mole fraction of the water times the vapor pressure of the water. Now the vapor pressure of the water, it told us, was 23.8 torr, right? 23.8 plus the mole fraction of the solute, the C6H12O6. Where's that? There it is, right? The mole fraction of the C6H12O6 times the vapor pressure, and it says it's not volatile at all, right? That's what the problem says. Therefore, this is 0. Therefore, that whole thing cancels out, and all we're looking at is the new vapor pressure being related to the mole fraction times the original vapor pressure. All right, and it says, what is the vapor pressure of the solution prepared by dissolving 65 grams of this stuff in 150 grams of water? Well, we need to find the mole fraction. Mole fraction. What is the mole fraction? The mole fraction of the water, for example, is the moles of water over the moles total. And the moles total is the moles of water plus the moles of the glucose, C6H12O6. All right? So, how many moles of water do we have here? Well, it says that we had 150 grams of water. So if we have 150 grams of water divided by 18 grams for every mole, right? Let's try that again. All right, so 150 divided by 18. .33 moles of water. Okay. So 8.33 moles of water divided by moles total is moles of water plus moles of this other stuff, glucose. And the grams of glucose was 65 grams of it, 65 grams. So if I take 65 grams and divide by the molar mass of glucose, which is 180, now it tells me 0.3611 moles of the glucose. So I take moles of water plus moles of glucose, right? And I take moles of water divided by this, which is now the moles total, right? And then I get 0.958. So that is the mole fraction, 0.958. 0.958 is my mole fraction. And again, my resulting vapor pressure is going to be the vapor pressure original times the mole fraction of the water. So 0.958 is the mole fraction of the water. The vapor pressure original was 23.8 torr. So 23.8 times 0.958. So my new vapor pressure is 22.8. Is that what the question was? What is the vapor pressure? All right, so 13.58, 22.8 torr. Okay, good job.